Hey guys, today I will discussing about Spark. So what is Spark and what is the use of this Spark? What kind of operations we can do with Spark? I will discuss in this session. So yeah, coming to what is Spark? Spark is like a super fast data engine. It can use it for processing the data. So Spark have coming with some features. Spark have in-memory computing. In-memory computing means Spark, and compared to the Hadoop, the intermediate results will write into again disk. But Spark will not write the intermediate results into the disk. It will be hold it into in a RAM. And you can think it in a RAM. So the Spark will distribute the data across the clusters. That means when we run the job, suppose we are reading the data from the another source files, the source file will be reading, while reading, it will be splitting into across the different nodes, every node trying to read some portion of the data. In that way, Spark will read the entire file in a fraction of seconds. Spark will support multiple languages. Compared to the Hadoop only supports Java, but Spark supports Java, Python, and Scala languages. Spark will come with unified engine. It means by using Spark, we can write SQL queries. We can write, it will support Spark streaming. We can write machine learning algorithms also. Spark will come with lazy evaluation technique. It means that once we write the any piece of logic, it will not execute immediately. It will be holding the blueprint. Whenever the action is called, then it will execute. To holding that kind of blueprint, it maintains one lineage graph. It is called we call as DAC model. So Spark will support the processing large data sets. Spark is used for ETL processing and analyticals and running machine learning workflows. Coming to the next slide. So this is how the Spark architecture looks like. It is supporting multiple languages like Scala and Java, Python. These are the things. And come to the internal libraries, Spark will help to write the SQL queries. It can be help for streaming jobs. It will be help for running machine algorithms. So these graphics and all, there is less projects are working, but most of the people working for Spark SQL streaming and machine learning algorithms. So coming to the next slide. So Spark have capabilities to read the data from the different source systems. Like Spark can read CSV files, JSON files, Parquet files, ORC is our file, one more file format will be there, and it will be connected to high tables, it will be connected to JDBC. One means in Spark, once the Spark section will be created, if you give the JDBC URLs, database connections, username, passwords, which table you want to read, it will be support and will load the data into Spark environment. It will support Cassandra database. This is a NoSQL database. The NoSQL database also Spark supports. You can read the data from S3 also. It will be supporting source Spark streaming purpose, Kafka, Kinesis, Elasticsearch, and it have capability to read the HDFS directories also. Spark is an independent library. It will not depend any Hadoop ecosystem. So we can separately we can install, we can work it. Coming to the next slide. See, in Spark architecture, suppose when we are reading the any data from the any one of the source, consider we are reading data from the CSV file, or else consider we are reading from the image and S3 buckets. When we reading this data, internally there are a lot of components involving. One is cluster and the driver and cluster manager and executors. The cluster means group of computers, or you can think like group of computers on one server will be there. So group here in Spark, group of machines we call as a nodes, or as we can call the executors. The driver program is a main program like in Java. There is a main program is it. Then how in Spark also have one main program. It will hold the Spark session, some context level information. And Spark also have one cluster manager. We need to use any one of the cluster manager, either Air or Mesos or standalone clusters. We can use a Kubernetes. Most of the people will use by Air and Kubernetes. As I told, executors are the real worker nodes. That means, suppose when you're reading the data from the S3 buckets, so we have to read the data in the parallel. So because of the fast computation to get the fast computation, so to parallel read means there are different machines there are different executors will read this data. Coming to the interesting use cases of Spark. Spark will use any e-commerce like Flipkart, any kind of like organizations are using for building some kind of recommendations and analyzing the log analysis, and finance industry like fraud detection, credit risk scoring in healthcare. In healthcare industry and telecom domain like event injection, nothing but like any clickable events happening while using any mobile like Wi-Fi routers, anything, and the marketing, customer segmentations. So these are the some of the common use cases will help Spark API. So Spark have three data abstractions layers. One is RDD, a data frame, and data set. Coming to the first, we come to the RDD. RDD is nothing but resilient distributed data set. That means that R means like resilient. That means fault tolerant. Even though while processing the data in a cluster, if we lose any data, again we can get that with the technique of resilience. Here the technique evolved to get that lost data. So RDD will be distributed. That means the data will be partitioning along different nodes. Data set, collection of partition data we can call as a data set. See, this RDD will come with a logic execution. Means that whenever the any action like a count, a collect is called, then only the actual results will come out. Unless the Spark will not execute any job, just will hold that the how I need to work kind of blueprint it will hold. This whole information will keep storing in a DAG model. So the next data abstraction is data frames. See, RDDs will, when we go with RDD means when the data is unstructured format. If data is unstructured, you want to do some analysis on the unstructured data, then write the code in the RDD formats. If you have data with already structured data, then you go with the data frames and write any SQL operations. It could be helpful. But compared to RDD, data frames are much faster because of internally it will use Catalyst and Tungsten optimizer. They will be helpful while query planning, those kind of stuff. So, but internally, data frame also use RDDs. Coming to the next one, here I will show a Spark snippet of code how we need to create a Spark session. Here I am using a Python as a language for creating this Spark session. So this is the main class. Under that we are using a builder and we are giving some name as a video demo. This app application, and in a cluster there are so many applications are running. To avoid them confusion, we are giving our application name as a video demo. And director create means if you lost a connection in any intermediate while executing the job, if you lost again it will be automatically create the session. For that purpose we are using the getter create method in this case. See here how we need to read the data CSV format. Suppose consider this is the data frame. We have Spark session. This Spark keyword will hold the Spark session. As you see here, we are assigning this Spark session all details into the Spark variable. Source Spark dot. See Spark dot read dot. We are giving the format also. Our data may be in CSV format. Please read my data. So this is a file location dot CSV we are giving here, and we are telling that my header is true. It means that a header is true means some files have a schema in the first in the schema, like suppose ID name kind of. Then it's because of comma separated, the file will be like something like age, this thing, ID will be 101, and name will be XYZ, comma, and the age will be some ZX. So there are like millions of records will be there. So if you want this schema also while reading 10, you need to header equal to true. You need to put the header equal to true. If you want like info schema, that means this data types also you need to say info schema is equal to true. So then we're trying to show the results. So show is kind of like print command. This is how we need to write the SQL queries. Suppose we already have like think like it has a data frame. So I create a temporary table name as a people. I will come on later on this, and we're trying to write the SQL queries on top of like Spark. This Spark it holds the Spark session. And we are telling like, hey Spark, this is I'm trying to write a SQL query. So on this location from this table filter we're applying some where logic which the age will be greater than 30. Show me the results. This SQL database will hold this all the results. Then we are calling it will show the results. This is an RDD style of writing the code. This is one of sample code. So here, like we're mentioning, we are using a Spark contest here. But consider this is a data file, and we are doing some we are applying some YAN, or these are the transformations or locale where in the menu we're using a lambda function. We're doing some multiplications like x into x there. It will again for using a squared purpose. So the print statement will square the and this is correct is action here. Will show the results. Coming to the data frame, so as I told, it will be supporting SQL queries, it will be supporting the RDD style of coding, it will be supporting the data frames also. With the data frames, how we need to do the transformations. This is a data frame dot df dot filter. This is a column is we are giving the column name as age. With the age will be greater than 25, it will be fetch all these records, and on top of that I am selecting the name and age on the which are going to about 25 age. And as of now we are discussing about how to read the CSV files, how to make a query and with the Spark, what is RDD, what is data frame, we discussed. On coming session, we'll discussing about the integration part, how we'll run the Spark jobs in AWS environment. So we read the data, causing that our data is present in S3. We're connecting to Glue. Here Spark jobs, we can write it here. We can do all ETL analysis in Glue. Then once the analysis is done, again we will write one of the table in Redshift. We will show these things in next coming sections, and there is one more section. I will talk about what is that, what internally happens, how the stages and how task will be created, and then in same way I will discussing about Spark submit command. There is lot of parameters will to pass for executing this Spark job. And we talk about the few things the difference between the Hadoop and Spark. Similarly, in Hadoop, the data will be storing in the replication factor. By default, we are storing the data in a three replicas. But coming to the Spark, there is no such kind of. We are not storing replication data because of this feature we can achieve via a DAG model. It means that when we lost that data, it will be like giving some graph to how to recompute the lost information. Thank you.